very outline notes, because there's a general principle involved here. And the general principle is everything is useful sooner or later. You'll hear some lectures at this meeting. I don't know how many talks there are going to be. I'm sure quite a number. Remember this. If one of them were to help you in your own work, save you 3 months, 6 months' time, that's a fantastic return on your time. And even if that doesn't happen, the chances are that 1 or 2 or 3 or 4 of the papers that you hear in 6 months' time or a year's time or 5 years' time can suddenly occur to you, oh, I heard in Cambridge that person talk about something and I think it might be just what I want. And you can Google them, or hopefully, and this is one of the advantages of meetings like this, you may know them, which is of course better still, then you can get in touch with them. And this is an enormous resource. Now, even if you've got very good memories, you need to keep some notes. Only perhaps outline notes, but just enough to refresh your memory. And I should confess on this, I used to do this very meticulously, and I stopped at some point, a good many years ago now, but I stopped. And it was a great mistake. I regret stopping. I should have kept going, although I used to have at least a tolerably good memory. It would have been better to have these notes that I could have gone back to. So that applies to reading journals, reading type A, reading type B, I mean, going to seminars, going to lectures. Remember the principle, everything's useful sooner or later. Then there's your research. Well, of course, you want to spend as much intensive time on this as possible. And, well, what more is there to say? It has to be thought about. Well, how you'll come across difficulties, and you have to just keep thinking about it till the difficulties are resolved. And I've already made the point, the time in thinking about this is limited. There's another thing to do about time. There's a word I can't quite remember. When you get it, you'll discover many, many, many years ahead, when you get old, words you never use in everyday life, even if they're common words, you have difficulty remembering them. There's a word I can't remember. Sheila, can you help me?
Holiday, perhaps?
Holidays, that's the word. I have a friend, Gillian, and she told my wife some years ago that the first time we met, Gillian came to work with me instead of working as a doctoral student with me a few years ago, and Jill says that the first thing I ever said to her was, your grant allows you 6 weeks holiday a year, but nobody, I said, could possibly want 6 weeks holiday a year. 2 weeks maybe? 3 weeks? Now, I don't know whether Jill was teasing me or not, but I do know if I didn't say it to her, I should have done. Sorry. Sheila, I'm speaking seriously, am I not, Sheila? I am, I assure you. Anyway, that's enough about time. Keeping notes I've talked about, in particular, keeping notes about ideas for research. You know, something crosses your mind, why couldn't we do so-and-so? It may be a crazy idea, probably most of them will be, but then items of suggestions of problems for research are gold. You must keep notes of those. I used to tell students, but I've got more realistic as I've got older, that you should keep a notebook by your bedside so that if you wake up in the middle of the night, you write, and with a thought in your mind, you write it down. Another thing I never actually got around to doing myself. But it's a good idea, because it's well known and well established, even in the very mathematical, even in pure mathematics, that very, very good ideas can occur in the middle of the night. There are many instances of people trying to prove some very difficult theorem and going to bed not knowing how to prove it and then waking up in the mysterious has happened. That's quite well. There's a famous book by Hadamard, a French pure mathematician, on that theme. So, thoughts in the sleep, whether the sleep's during the day or the role of mathematics. Now, of course, if you're in probability, obviously a powerful mathematical basis is crucial. If you're in applied probability, by which I mean, for instance, applied stochastic processes applied to, shall we say, infectious disease epidemiology or operational research, perhaps a different sort of mathematics will be of great help, although simulation was an increasing temptation, which I don't like, I have to admit, that these issues are best dealt with by simulation. What in that sort of area I think is needed is some mixture of mathematical analysis of so-called toy models, simple abstractions of real epidemics or real operational research problems or whatever they might be, and then simulation studies of more complex systems. The more mathematics, the better. In statistics, again, everything is useful sooner or later. The more mathematics you have, the better. But many highly successful research mathematicians, certainly in the past, research statisticians rather, but certainly in the past, and I think still perhaps even increasingly today, have very limited mathematics students who invented a student t-test. I don't know how many of you know much about Student's background. He studied chemistry, he had some mathematics in his first year as a chemist, and he knew some elementary calculus and a bit more than that. But he invented the student t-test and student t-distribution and so forth, and he did that with his very limited mathematics, bit of primitive simulation and some clever guesswork. This was 1908, something like that. There were many mathematicians before that who could perfectly well have done all this, but they never thought of the question. He posed the question. And he didn't write many papers, but they're all of this kind. The mathematics is very elementary. The science and the probing is important. And he uses what mathematics has got highly effectively. He was a chemist, as I said. He was employed by Guinness's breweries in Dublin. And when Guinness's moved, they didn't live in it. They're still very much in Dublin, but they opened a large factory in Park Royal in northwest London. And Student was the managing director, basically, of this new plant when he died. So he had a highly successful career as an industrial manager, industrial chemist, a research worker, a statistician, based on very limited mathematics. Now another anecdote too, well, it's not an anecdote, it's a true situation. A friend of mine was analysing some medical data, and he had seen that Bradford Hill and Dole, who are very, very distinguished statisticians, epidemiologists of a slightly earlier period, had a very similar set of data, had analysed it, and my friend couldn't understand what Bradford Hill and Dole had done. So he set up a mathematical model, he solved some differential equations, he got a likelihood, he developed a method of analysis, he applied it to his data, and then he went back to Bradford Hill and Dole's data, and he discovered that his method of analysis was exactly the same, not approximately the same, but exactly the same as what Bradford Hill and Dole had done. But they got there by some penetrating insight into how the data had been obtained and what was going on there, and some unstated understandings of what to do. Now the moral of that is, there are two morals. One is that important things can be done with very limited mathematics. But the moral isn't that the mathematics is unimportant, because my friend's analysis, first of all, it showed exactly what the assumptions were, made it much clearer to everybody else. And secondly, it indicated the way, if similar problems but slightly more complicated or slightly different were to come up, then the mathematical approach to tackling them would be clear. So the mathematics would be highly fruitful. The role of competition in research. Research is a competitive business. You want to get your results first. If somebody else is working in the same field, you want your results to be nicer and better than theirs. And competition is a useful spur. I don't want to get political, but competition carried to excess leads to a kind of lunacy. And you don't have to perhaps look too far in the outside world to see that. I think, and maybe I'm over-optimistic, I look in the statistical community and I see sensible competition. I see very, very little, very few cases where people take excessive competition. There means thinking that propagating, pushing forward their own career and their own interests outweighs the advancement of science, the advancement of knowledge. I see very, very few cases. I'm sure there are instances of that. If you see that, keep out as far as you can. It's destructive in the end. So competition is a good thing, but the research community, statistical research community, I think, has it in reasonable control, in a reasonable balance. Writing, as your work progresses, write it down, for goodness sake, don't leave writing up to the end. If your work gets to the point where papers can be submitted for publication, something you have to discuss with your supervisor, don't go over the top about it, but if you can get stuff published before your thesis is submitted, I think that's a good thing. Not everybody agrees, not every supervisor agrees with that, but I do. Partly because if things are worth publishing, they're worth publishing, might as well do it straight away, and partly because I think it's an issue of encouragement, that it's an encouraging thing to do. Then finally, I started out, my notes say I should talk about the duties of the supervisor. What about the duties of the student? Well, there are two really. One is to work reasonably hard, but the other is to contribute effectively to the education of your supervisor. And that's very important, particularly for supervisors. And you contribute to the education of your supervisor in two different ways. One is by reading things or going to talks they don't go to and tell them about it. You heard this interesting thing, and tell them about it. But the more important thing to do is to ask them questions they can't answer. I don't mean riddle, I don't mean statistical versions of why did the chicken cross the road thing, but serious questions. Because research is, in a sense, almost more about, particularly more methodological and more theoretical research, is almost more about asking sensible questions than it is about answering. If you ask a sensible question that's not already being answered, if you ask a sensible question, you can put together some sort of answer. It may not be the ideal answer, it may not be the perfect answer, but it will be an answer. But if the question isn't very sensible to begin with, well, so what? So asking sensible questions, asking questions that are difficult but not impossible. As I said earlier, asking questions that nobody can answer, grandiose questions on an enormous scale. That's not what scientific research is about. But we're asking questions important, interesting, and doable. That's perhaps the most difficult part of all. I don't think I have anything else to say, but I would very much welcome questions.
yes, so if we just thank